Today's topic is waveform synthesis, wherein a waveform would be given to you, okay, graphically. So that graphical waveform needs to be expressed mathematically in terms of basic signals or in terms of combination of basic signals. Okay, so that is what is synthesis means generation. Everybody understand? Synthesis means generation of a waveform. So how to generate a waveform? So they would be given a waveform which can be expressed in terms of the basic signals or in terms of the combination of different basic signals. So that is what we need to learn here. Okay, so there will be sketching of signals in this particular topic. Okay, so let's move on with the first waveform synthesis problem. Okay, it's again Laplace transforms only. So they'll be asking you to obtain the Laplace transform of a given signal which is given in form of waveform. Okay, but we don't know how to apply Laplace transform directly to a waveform. So what we need to do, we need to obtain the mathematical expression, right? So that is what is being called as the waveform synthesis. Okay, or in simple terms, you're trying to get the given waveform in terms of the mathematical expression before you apply the Laplace transform. So everybody, let's see the first waveform here. Okay, the problem is this: they say that they're asking us to express. Everybody, take down this. Express the current pulse I of t. Okay, in terms of unit step function. In terms of unit step function, you need to obtain the given current pulse I of t. After you do that, find first one Laplace transform of I of t. Okay. Second one, Laplace transform of integration of I of t with respect to t. So this is what we need to do. Okay. Now we shall see how the current pulse I of t looks like. Everybody just copy down this. The I of t is what we are sketching now. So I of t is what we are writing. Fine. So let's have this. Uh, so this is how the waveform is looking like. Okay, 0, 1. Okay, so at 2 it reaches again 0. Fine, comes here 2, 3, and at 4 again it goes to 0. Okay, what is the amplitude? Amplitude is C 5 here and -5 here. Okay, so this is what is the problem, the unit step functions. Now we should understand there is a waveform on the positive side, that is +5, as well as there is waveform on the negative side, that is -5. Okay, so everybody understand this. What is unit step function? See here, unit step function u of t is what? It's 1 for t greater than or equal to 0 and 0 for t less than 0. This is what unit step function is. So how do we sketch that? We sketch it like this. So it is 0, this is t, Again, this is 1 for t greater than or equal to 0, or 0 for t less than 0. But it is 5. See here? But the amplitude here is 5. Amplitude of I of t is 5. Okay, so if I want 5 there, okay, what I need to do? I need to multiply this particular signal by 5. Okay, if you multiply this signal by 5, what would happen to this? So you are multiplying the amplitude by 5, so it becomes 5. Everybody understand this point? So how to obtain a unit step function of amplitude 5? By multiplying 5 to u of t, we can obtain that. Okay, and it's not only obtaining unit step function which is of amplitude 5 and starting at 0, but we need to also obtain a signal which is having the amplitude minus 5. Get that point? So how to get this is another thing that we need to think of. Okay, now understand, I'll give you have to use two versions of u of t. One is phi u of t. You have to use another version of u of t, okay, to get this. Fine. Now everybody understand. From 0 to 2, I need a signal of amplitude 5. Let me write that here. Everybody just concentrate. See here, this is 0, okay, 1, 2, 3, 4. Let it go on and on and on. Okay, till here, I want a signal of amplitude 5. Okay, so that means from here to, suppose this is phi u of t, right? And this is some signal. So this signal phi u of t minus the signal which is starting at 2, let's say, which is starting at this point. Okay, so if you subtract, let's say this is, suppose x of t. Just assume that this is x of t. What is phi u of t minus x of t from 0 to 2? What is phi u of t? What is phi u of t minus x of t from 0 to 2 means here? From 0 to 2 it is 1. Sorry, so from 0 to 2 it is 5, and from 0 to 2 it is 0. So 5 minus 0 would give you 5 from 0 to 2. So that means we will have a waveform which is 0 from 0 to 2. Why I need to have a waveform which is 0 from 0 to 2? Because if I subtract this particular signal, okay, from the first signal, that means if I subtract x of t from 5 u of t, from 0 to 2, what I'll have, that is 5 minus 0. So you'll have 5 from 0 to 2. Let me write that. Okay, so what I'm trying to do is this. Everybody just see this. Let's not hurry, okay, in doing this. So what I'm doing is this: 5 u of t minus x of t. I don't know what x of t is. Let's see. Okay, what is that we are going to get? Okay, so from 0, 1, 2, we will get what here? 5 minus 0 is what? This is 5 and this is 0. 5 minus 0 would give you 5 only. From where to where this would happen? From 0 to 2 this would happen. From 2 onwards, what do I need? From 2 onwards, I need minus 5. We have 5 here. Okay. Okay. If I want minus 5 here, when I subtract x of t from 5 u of t. So what do I need? Okay. What do I need from this point onwards? From 2 to 4, what do I need? Is the question. At least from 2, what do I need? See, suppose if I have minus 5 here, what would be the signal at 2? It would be 5 minus 5. Isn't it? 5 minus 5 would be 0. It will come and stop here. But I need a signal which would go beyond that. Understand that? So if what do I need here? I need -5. So how to get -5 here? How to get, everybody understand? How to get -5 here is the question. Fine. So if this is 5, if this is 5, what would happen? 5 minus -5 would give you what? Plus 10 it would give you. No, I don't want that. Okay. What do I need? I need rather this is sorry, this is even if I add this also will get the same, right? From 0 to 2, 5 plus 0 is 5, or 5 minus 0 is 5. So if you add also you'll get the same. Okay, now if you add 5 and -5 it would be 0. So I need something like this here. See here, everybody, just observe. I need a signal which is -10. If it is -10, what would happen? 5 minus -10 would give you -5. So what do we need here is, see here, which are the signals do I need to obtain the given signal? One is 5u of t I need. Okay, 5u of t is what I need. Fine, in that 5u of t, I'll have a signal of amplitude 5 from 0 to infinity. 0, 1, 2, 3, 4. Okay, like this. Then I need another signal which is -10 u of t minus 2. Why t minus 2? Because see, this is where I want the signals to start. Okay, and I want that signal to have the amplitude what? -10. Okay, so let me do this. So this is -10. Fine, and where is it starting? It's 0, 1, 2, 3, 4. Okay, this is t again. Now, what shall we do? This is -10 because the amplitude is -10, and where is it starting? It is starting at 2. So it is u of t minus 2. So what do I need to do? Now, everybody just see here. What I do is this. I do 5u of t, okay, minus 10 u of t minus 2. I'm subtracting. So what would happen if I subtract? See here, everybody, I'm subtracting 10u of -10u of t minus 2. I'm subtracting from this, or I'm adding these two signals. Let me say, I'm adding these two signals. 5u of 10 minus 10u of t minus 2. I'm adding. So from 0 to 2 it is 5. From 0 to 2 it is 0. So 5 plus 0 would be 5. From where to where? From 0 to 2 it is 5. 0, 1, 2. It is 5. From 2 onwards, what would be? From 2 onwards, it is 5. Okay, it is -10. 5 minus 10 is -5. It would be -5 throughout. So this is -5. This is 5. But this is not the given signal. What is the given signal? Given signal is this, which would become 0 at 4. So how to make this 0 at 4? What we can do to make this signal 0 at 4? 2, 3, 4. So that means at this point it should be 0. So what I can do, if this -5 has to become 0, means I need to add +5 to this. So what I can do is, see here, everybody, I need a signal. I need a signal which is 5 from 4 onwards, which is 5 from 4 onwards. So what is this signal called? 1, 2, 3. Yeah. Can you name this signal? Anybody would like to go for that? What is this signal?
5
This
u of t minus 4.
5u of, very good. It's 5u of t minus 4 because it is starting at 4. Now, what we need to do, we need to add this signal and this signal. Why we are doing that? Because I need a signal which is 0 from 4 to infinity. So from 4 to infinity it is minus 5. From 4 to infinity it is plus 5. So minus 5 plus 5 would give you 0. So what I would do is this. What I'll be doing is you have 5u of t minus 10u of t minus 2. To this signal I'm adding plus 5u of t minus 4. So if I do that, I'll be availing this. See how from 0 to 4 there is some signal. This is what I'm saying. From 0 to 4 there is some signal. Okay, so that signal plus 0 would give you the same signal. Everybody is okay with that? Yeah. From 0 to 4, 0, 1, 2, 3, 4. You have the same signal. From 4 onwards, okay, from 4 onwards, this is minus 5 and this is 5. So if you add these two, okay, so this is what you're going to get. Okay, so what is this? What is this signal? This is the given signal. Everybody see here? So I of t is what is this? So this is 5 and this is minus 5. Okay, so now this is what is our given signal in terms of u of t. Okay, so this is the given signal. So therefore I of t in terms of unit step function is, okay, so you have to just write this expression. I of t equal to 5 u of t minus 10 u of t minus 2 plus 5 u of t minus 4. So this is what is your given signal mathematically represented. Get this point, everybody? Now what we need to do from here on? From here on, what we need to do? We need to apply the Laplace transform of this. That is what is asked. Everybody see the problem statement. They've asked us to obtain, okay, Laplace express I of t in terms of unit step function. That we have done. So after that, we need to obtain the Laplace transform of I of t. Okay, so question number 1 after that is, okay, call this as 1. Apply Laplace transform on equation 1. Okay, how is that going to look like? Yeah, everybody see this. Let's apply the Laplace transform on 1 now. So how does it look like? If you apply Laplace transform, it is applying Laplace transform on I of t. Okay, then applying Laplace transform on whole of this. 5u of t minus 10 u of t minus 2 plus 5u of t minus 4. Okay, so then I can say using linearity property. How does it look like? Using linearity property, Laplace transform I of t can be represented as I of s. Okay, so by linearity, I can keep 5 out and I can apply Laplace transform on u of t. Okay, similarly, I can keep 10 out and apply Laplace transform on u of t minus 2. Fine. Keep 5 out and do the same on the last term. That's u of t minus 4. Now, which property do we need? Okay, here it is straightforward. We know the Laplace transform of u of t, but it is the shifted version of u of t. So it is time shifted version. So what do we need to do for the time shifted version? What do we need to do? Needs to be seen here. Okay, fine. Anybody would like to do that? Everybody try doing that. We have to apply the Laplace transform time shifted version. Let's write that by time shift property. Laplace transform on time shifted version of this is e power minus t naught s into x of s by time shifting property. Okay, so therefore I of s can be written as 5 Laplace transform of u of t is 1 by s. Okay, minus 10. What is Laplace transform of u of t minus 2? Okay, Laplace transform of u of, this is what, this is Laplace transform of x of t, right? What is x of t here? X of t is u of t. So what is Laplace transform of x of u of t is 1 by s. And since it is minus 2, we need to have e power minus 2 s divided by s. Okay, similarly plus 5 e power minus 4s by s. So this is what is applying Laplace transform on I of s. Okay, this is Laplace transform of I of t, which is represented as I of s. Everybody is okay with this? Now what is asked? They have asked us to find out the integration of. Okay, so this is the equation number 1, right? So in equation number 1 we have I of t. So this is what we did. This is what we did now. Now they are asking us to obtain the Laplace transform of the integral of this. Understand that? So you should understand this now for the second one. Consider again I of t equal to 5u of t minus 10u of t minus 2 plus 5u of t minus 4. Okay, so you should understand this. We know that this is not told to you maybe, but understand, if you integrate u of t with respect to t, okay, you will get what? You will get r of t. What is r of t? You understand that this is ramp. Okay, so therefore integrating, this is equation number 1 only. This is equation number 1 again, consider. Therefore integrating equation 1 implies what? Integration of I of t dt is equal to 5 r of t, because if you integrate u of t, you'll get r of t minus 10. If you integrate u of t minus 2, you'll get r of t minus 2. Similarly, if you integrate u of t minus 4, you will get r of t minus 4. So we got the integration. Now what we need to do, we need to obtain the Laplace transform on the integration of I of t. Okay, so that is equation number 2 for you. This is equation number 2. So applying Laplace transform on 2 now. Okay, therefore applying Laplace transform on 2 implies what? That implies Laplace transform on integration of I of t dt. That is your second question. Okay. So what is Laplace transform of r of t? It is 1 by s. R of t means it's t. Okay. This is t, mind you. Fine. So it is 5 by s square. Laplace transform of t is 1 by s square. Okay, what is Laplace transform of r of t minus, this is shifted version. Okay, so since it is shifted, you will have e power minus the shift into s divided by 1 by s square, divided by s square. Similarly, plus 5 into, okay, e power minus 4s by s square. How did we do this? By time shift property. By time shift. Why 1 by s square? 1 by s square is because the Laplace transform of r of t is 1 by s square. Understand that? In previous case, Laplace transform of u of t is 1 by s. That's why it is 1 by s. For the shift, it is e power minus 2s. For the shift, it is 1 e power minus 2s. For u of t, it is 1 by s. Similarly here, for shift, it is e power minus 2s. Okay. For r of t, it is 1 by s square. Okay. So if you're still not good with that, okay, so you can see this. You can directly go to the properties here. No, here, rather you can go to the standard transforms here. If you have u of t, it is 1 by s. If you have t, it is 1 by s square. What is t? T is your r of t. Okay, so this is nothing but your r of t, mind you. Ramp, unit ramp. Is that okay with you? That is why by time shift property, we are able to write this. Is everybody okay with that? Fine. So fast, let's take another problem. Everybody take this problem number 2. Express the Sawtooth waveform. Everybody copied on this. Express the Sawtooth. I'll show you what is Sawtooth waveform. Express the Sawtooth waveform in terms of singularity functions. Singularity functions means basic functions. Using the basic functions is what they mean. Fine. So the Sawtooth waveform that they're asking is this. So this is T. Okay, and they have named the Sawtooth waveform as V of T, and the Sawtooth waveform is this. Okay, 0, 1, and this is 5. The amplitude of this waveform is 5, and the width is 0 to 1. So what they have asked us is this: find Find Laplace transform of v of t is what they have asked us. Okay, so what we need to do here, we need to obtain this sawtooth waveform in terms of singularity function. Singularity function means it could be any of the unit step, it is any of the basic functions or combinations of basic functions. Okay, so what you need to understand here is which two basic signals are involved here is what we need to understand. Anybody would like to give a try? Which two basic functions are basic signals are hidden in this? You should give me that. Okay, I'll just explain you this in the solution. It is very easy. If I give you, it's easy. If I want you to do it yourself, you may have to think a bit. Okay, I'll do this problem now. Okay, you just have to see this. Maybe from next problem onwards, you would have the idea to do this. Okay, I'll give you the two basic signals that are hidden here. Okay, now I need a signal which is 0 at 0, okay, and which is 5 at 1. Anybody knows that? Okay, I'll
Unit
write a,
ramp function.
yes. See, I'll write something.
Unit
Just
ramp
tell me
function.
what is this. See, I'm writing. This is ramp, right? Okay. If 0 at 0, it is 0. At 1, it is 1. Okay. At 2, it is 2, suppose. What is this? This is slope 1. This is ramp of slope 1. At 1, it is 1. At 2, it is 2. At 3, it would be 3. Okay. So this is called as R of t. Okay. Now I want 5 at 1. See, I want 5 at 1. That means I'll be having 10 at 2. Understand? This is how it is happening. So if I'm multiplying 5 to this, means I'll be multiplying 5 to this also. So that means I need a ramp whose slope is 5. Why the slope would become 5? Because it is x by y by x, right? So it is y is 5, y is 5, and x is 1. So 5 by 1. So slope is 5. So this is what I want. So you consider a ramp of slope 5. Okay, so let's call this as 5r of t. If you call this as 5r of t at 1, okay, so it will be having an amplitude 5. Now this particular function is 0 beyond 1. So I need to do something so that I'll have this signal ranging only from 0 to 1. So can you tell me what we can do? We need to have this particular signal just from 0 to 1. From 1 to infinity also it is there, but I don't want this part of the signal. I want this signal only from 0 to 1. So what I can do? Can you think now? What I can do? I only want this signal from 0 to 1. So what I can do when I can have that? Everybody just see here.
Using delta function.
Using delta function, no. If you multiply delta function, where is delta function existing? Delta function is existing only at t equal to 0. This is what is delta function. So if you multiply this for this, what is going to happen? Nothing is going to happen actually. Okay, so at only one point at t equal to 0 is what you're operating. I need something which would make it retain the signal from 0 to 1. If you multiply it by delta function, you will lose the signal from 0 to 1 also. Whatever is there at 0, only that will remain. Okay, I want a signal which would range from 0 to 1. Okay, so what is that signal? See here, everybody, I'll give you the signal. Tell me which operation can be performed on this. Here, think that this is a signal like this, and it is 1. Since the 5 is written here, okay, I wrote my 1 here. So This is the signal I want. Which is this signal? Can anybody tell me which is this signal? Which is this signal? There are two u of t hidden. Okay, one is a u of t which is starting at 0. Okay, and I need another u of t which is starting at 1. Okay, so this is u of t, this is u of t minus 1. So if I perform u of t minus u of t minus 1, I'll be able to get this. Everybody understand this point? Okay, so now this is these two signals I've given you. So how you can, what operation you need to perform on these two? Okay, what operation you need to perform on these two to get this particular signal? Okay, think for a while. Okay, you can bring that equation with you for tomorrow's class. Okay, we shall end today's class here.